All right. Well, I'm here, so if you guys have any questions, go ahead and ask. We got about 5 minutes before officially starting the class. Oh, right. I forgot to put the link into Discord, so let me do that first. There we go. All right. There we go. We only got 3 lectures left, and one of those lectures will be a review for the final exam. So we only got 2 more lectures, including today, to talk about topics. So we are pretty much at the end of the semester. What an interesting semester it was. Still is. So no questions? Did anyone get a chance to look at the ungraded assignment that I put up in the announcement? All right, cool. So let me know if you have any questions. Because I think being able to follow the pseudocode and do it by hand, using a spreadsheet or even on a piece of paper, is going to help people understand the algorithm a lot better than just listening to me explaining it. Yeah, all right, cool. That's the intention of the practice. And I also specifically designed that graph so that certain vertices will need to be revisited. In other words, the algorithms will find the path, and if it goes like, oh, this is not the best one, and then it will do it again. Particularly the A star algorithm in this case will re-explore certain vertices. All right, and we got 2 more minutes before starting the class. I changed my headset again. So, I hope this one works out okay. I was listening to my own lecture yesterday, and it sounds okay. I mean, it didn't pick up a lot of noise and picked up my voice just fine. But if you notice anything not right about the recording, go ahead and let me know. And I'm also double checking to make sure that the recording at YouTube also has got the audio, because I forgot to change the settings for one of my YouTube sessions. And so the live stream from Discord was okay, but it recorded a soundless session in YouTube. All right, about 1 minute left. So for those of you who are planning to sign up for classes in the fall, just kind of keep in mind that some of the classes may, or I should say most or all of the classes may turn into online depending on the situation. So even if it was face-to-face, in the catalog, they still might have to turn it into fully online or remote. Yep. Well, at least for the time being, Carol. And this is really hard for certain classes like welding or nursing. Um, so that's going to be interesting for those people. Weightlifting, oh yeah, that's definitely going to be interesting. Although they might just tell you, find some heavy objects in a house and lift it. Oh, okay. Wow. Yeah, I suppose there's not much. Well, there are two issues here because one is whether the professor has the equipment to go online. I already got all the equipment with me. And then the second thing is with a weightlifting class. I suppose they can still talk about techniques and the theory behind doing all that stuff. And people can kind of set up a video recording of them lifting weight at home, or doing something like that. All right. Okay, I see. Well, this is the reason why I keep the same time slot on the same days, as the as this class when it was still face to face. Is I need that structure as well. So I'm keeping this time, keeping this these days, just so that I remember to do certain things on certain days. So that's kind of important. All right, I'm just gonna wait for Alexander and Carol to finish this. Yep. Absolutely. Oh, well, you're welcome. Yeah, structure is really important, and I think that is one of the issues of going online. Is people, including myself, okay, just are not getting used to things when there's no particular structure to it. So I have to keep a structure, and that's for myself. Cool. All right. So what we'll do today, unless there are questions about the ungraded assignment from last time, and I can show you the picture of that because I got it open over here. Let me move the window over. So this is the ungraded assignment. I don't want it to be graded because I want you to use both algorithms to give it a try, and I will give you the solution next week. So you have over the weekend, 4 days or so to work on this one and try to work on it as much as you can. I don't think it's going to take too long. Okay, once you start to understand the algorithm and understand what it's really trying to do, go beyond the symbols. It should not take too long to finish this particular trace. But I still want you guys to go ahead and do it. And then on Monday, I will give you the solution. So what you can do on Monday is look at my solution and then look at your trace and compare those two and see if there are important differences. If there are important differences, like the ordering of how the vertices are explored, then you need to find out why that is the case. Okay, did I detect follow the algorithm incorrectly, or did you follow the algorithm misunderstanding a particular step? So that's kind of important. Okay, it's okay. We don't have to finish it now. The intention is to give you guys about a week to work on this, just so that you can work on it not in a rush, but work on it, by understanding the algorithm, doing it kind of slowly. And this also gives you an opportunity to compare the two algorithms. Okay, now the comparison is not fair because I specifically designed the heuristics to trick the A-star algorithm so that it has to go back and a few times to re-explore to find the shortest path. But it is still a good idea to compare the two algorithms because they are different. Okay, excellent, cool. All right, so what we'll do today is to move on to talk about predicate calculus. So when you go to the class notes, it's basically it's the last module or the last group of modules in the class notes. Okay, and this is kind of fun too. If anyone has started to read about the predicate calculus page, it's actually kind of interesting. And you don't have to install anything to play with it because there's a web version of SWI Prolog. And this is interesting in some other ways as well, because we talk about AI or artificial intelligence, machine learning, and all kinds of stuff. And these days, most people associate AI and machine learning mostly with neural nets. Okay, and predicate calculus was actually one of the AI research areas, but it is not based on neural net. Predicate calculus is kind of the big brother of propositional logic. Okay, so I hope you guys still remember propositional logic. But predicate calculus is kind of like a bigger brother, because the one thing that propositional logic does not do was quantifiers. Okay, so we never put quantifiers like for all there exist into the statements that we process in propositional logic, and that was one of its greatest weakness, is it cannot deal with quantification. And so predicate calculus is basically one step on top of propositional logic, and it can deal with quantifiers, and that's kind of one of the main things about predicate calculus. So this module is relatively short. It talks about predicate calculus, but using Prolog, which is a programming language, as a way to explore what does it mean when I specify this, in predicate calculus. What does it look like in Prolog, and vice versa? Okay, so this is going to be a fun thing, because we can actually try things out as we go along with this. So we'll start with the syntax of Prolog. And instead of just kind of going through all of this stuff here, you're going through all the mathematical notations, we'll jump straight into something that is a little bit more fun. Okay. And 2 days ago was May the 4th be with you day. So this is usually pretty close to that date when I introduced this topic. So this line here, what I have just highlighted, is a valid clause in Prolog. Okay, and all it says, okay, is a Jedi is the name of the predicate, and then Luke Skywalker with a lowercase l is the name of what we call an atom. Okay, so when I say an atom, okay, it simply is a thing in the entire universe, or at least the known universe that the predicate calculus system is supposed to handle. Okay, so it's just an element in a set. Okay, Luke Skywalker is no more than just an element in a set, and then the predicate is a Jedi is kind of like it's kind of like a variable in propositional logic, except it is parameterized. Okay, so it can tell whether a particular atom in this entire universe is a Jedi or not. But at this point, we only got one single element in this entire universe, which is Luke Skywalker. All right, so let's go ahead and start up the web version of SWI Prolog, and you guys can do it. You do it with me too. You don't need to sign up for anything. You just kind of start using it. Let's see. No matching files. Okay, and the query goes here. Based on empty. Oh, it actually remembers my profile. And I can upload a program in order for this to work. So I cannot just type a program interactively. I have to upload the program here. Okay, so, and I can also, okay, I take it back. I can actually put my Prolog rules and facts in here. So the clause that I just mentioned, which is a Jedi, in parentheses, Luke Skywalker, is basically quote unquote a fact. Okay, it is just saying that Luke Skywalker is a Jedi. Now the name of the predicate is basically self-documenting, and you can basically choose any name you want to, as long as it is alphanumeric, starting with a letter in the alphabet. Is going to be okay. So in addition to this, we can say is a Jedi Obi-Wan Kenobi. Okay, so I'll just say Obi-Wan. Obi-Wan. I think that's the correct spelling. Okay, so now we have two facts in this entire system. Okay, So you can state facts, as much as you want, okay? And you can use different types of predicates to associate different properties to an atom, okay? So you can also, indicate the gender of a particular atom, okay? So you can say, Luke Skywalker is a male, okay? So you can say is a male, and then we have Luke Skywalker over here. So you can basically, add additional facts by introducing additional predicates and so on and so forth. So far this is not, it's not really too interesting, because all we are doing is data entry. We are just inputting what we know about the atoms into, quote unquote, the database, okay? But it's not really a database, so do not think about this as a relational database. It can do a lot more than that, okay? All right, so switching back to the notes over here. So this particular statement is a Jedi Luke Skywalker with a period after that is really the shorthand of this thing over here. So now the question is, what is that doing? What is true doing on the right hand side of the colon dash symbol? Okay, so as it turns out, this is the syntax of prologue, and it is supposed to be read backwards. Okay, if this is actually an implication, but the implication goes the other way around. It basically says true implies Luke is a Jedi. Luke is a Jedi, basically. Okay, but in order for the implication to be true, if we start on the side that is true, and true implies Luke is a Jedi, and if the implication itself is true, that means Luke really is a Jedi. Okay, there's no question about the value of that particular predicate. All right, so do we have any questions about this part here? I know it's confusing. Okay, the other way to look at this is Luke Skywalker is a Jedi is implied by true. So it is opposite, okay? Because normally when we write an implication, it is the left-hand side that implies the right-hand side. But when we specify those rules in prologue, it is exactly the opposite. It is the right-hand side that implies the left-hand side. So are we okay so far with this? Are there any questions about the syntax? Okay. So let's take a look at something that is a little bit more interesting, okay? Because someone can claim that, that person is a Jedi, or that being is a Jedi, but if that person does not own a lightsaber, I am sorry, but you are not a proper Jedi without a lightsaber. So let's take a look at this particular rule here. Okay, and I'm going to read it from left to right, and then we'll interpret it by kind of looking at it from right to left. Okay, so from left to right, it is saying that X, now this time you can see X is an uppercase, and anything that is an uppercase in prologue is a variable. Okay, so a variable is not an atom. It can bind to an atom. It can also bind to another variable, but it is not an atom itself. Okay, so this X is really just a placeholder. Okay, all it is saying is we can call X a proper Jedi, but only if. Okay, so remember, if you read it from left to right, this symbol is saying only if. Okay, X is a proper Jedi only if the following is true. What about the following? The first thing is X has to be a Jedi, X owns Y, and then Y is a lightsaber. Okay, so to read the entire thing, okay, this rule literally says right here, okay, because I put the English version of that clause in prologue into here. X is a proper Jedi is implied by X being a Jedi, X owns Y, and Y is a lightsaber. So that means each lightsaber of this entire universe has to be represented as an atom as well. Okay, so each one has to exist as an atom, and it has to have the predicate is a lightsaber being true. Okay, so let's go ahead and take a look at the following. So I call Anakin's first lightsaber, which has a blue flame or blue edge. I call it Anakin Blue. So Anakin Blue is a lightsaber is a fact, okay? Because it does not depend on any actual conditions. It is true as stated. And then the other one is Luke Skywalker owns Anakin Blue is also true. Now, I did not put timeline consideration into this because Luke Skywalker cannot own this particular lightsaber when Anakin owns the same lightsaber. So I did not throw the concept of time into these predicates, but potentially that can happen. In other words, you can specify a time frame as another parameter to each predicate to control the time frame in which who owns what, okay? But I did not throw it in just for simplicity purposes. So what we'll do is we're going to copy and paste these two clauses to the other one, and then we'll copy this one as well. Then we can start to ask some questions, okay? So we'll go back to this interface, and this time we'll start to say is a lightsaber, and the name of the lightsaber is Anakin Blue. Okay, and that is known just as a fact. And then we can also now say who owns it. Okay, so we can say owns, and then the first item is the atom who is owning, and then the second item is the atom that is being owned. So it's Anakin Blue, like so. This is also just a fact. So now we can put in the last rule. Now you can actually do something that's kind of fun, which is looking at the facts, and you can ask questions, which is in the form of a query. So let's go ahead and ask the query, who is a Jedi? Okay. In other words, I'm saying is a Jedi, but this time I use a variable X in place of an actual atom. So I'm really asking a question, who is a Jedi in this universe? And when I press Control Enter, it tells me that the first match is Luke Skywalker. And here's the fun part. If you click next, it will also say that Obi-Wan is a Jedi as well. So the prologue is not just a programming language. It is a reasoning engine, so that if you ask a question, it will try its best to answer the question. Now, we can also ask a question like, is a Jedi? And you can put in something or some object that is not a Jedi. So you can put in Anakin Blue, which is supposed to be a lightsaber, and it will answer the question. And it says, okay, so I can't have two queries because it's appending the second query to the first one. So is a Jedi, and this time we ask about Anakin Blue, like that. Press Control Enter. Anakin Blue, Control Enter. Then it'll say yes, it is true. Okay, so this is actually quite an interesting engine because it would actually explore possibilities and then try to give you an answer. Okay, if you give it non-variables, if you specify everything in atoms, then it becomes just a fact check kind of thing. Okay, it will still exercise all the rules involved to answer the question, but it will just tell you whether it's true or false. On the other hand, if you involve the use of a variable, then it will start to try to figure out the answer. So now, in addition to all of these facts, okay, we'll start to introduce a rule, which is a proper Jedi. So we'll now say is a proper Jedi, okay, X. So X is a variable once again. So we'll say X is a proper Jedi only if, okay, the colon dash, if you read it from left to right, is saying only if. Only if X is a Jedi. So we have to start with is a Jedi, X. A comma means conjunction or and, so we'll just use a comma instead of spelling out A and D, or use ampersand, ampersand to imply that this is actually a conjunction. So we'll say owns, okay? So X has to own something called Y, which is also a variable. And then we have to now say is a lightsaber Y, okay? So this is a rule. In other words, by itself is a proper Jedi X does not tell you any fact. Okay, it doesn't say anything or anyone is a proper Jedi or not. But then you can ask it questions here. Okay, in the query, you can now say is a proper Jedi, and then you can use a variable X. Okay, so this is interesting because we have two Jedis. We have Luke Skywalker, we have Obi-Wan, both being Jedis. But in this particular universe, based on the facts that are already entered into onto the left-hand side of this window, only Luke Skywalker qualifies as a proper Jedi, because in this universe, Obi-Wan does not own a lightsaber, at least not yet, because that fact has not been typed in yet. So if I press Control Enter, in the query window, it will go find Luke Skywalker is a proper Jedi, and then if I click Next, it will just say, nope, I cannot find anyone else who is a proper Jedi. Now, the reason why it returns false is because it was able to find another Jedi, okay, being Obi-Wan. But it cannot make Obi-Wan own a lightsaber. There are no facts to support that Obi-Wan owns a lightsaber. So eventually, this entire right-hand side of this rule evaluates to false. And that's why it reports, false over here. Whereas before, it found two atoms, both satisfying, is a Jedi completely. And as a result, it did not return the last one as false because it was not able to make there's no right hand side to turn into false. As opposed to is a proper Jedi has a right hand side where you can partially match one or even two of the predicates on the right hand side, but if the third one fails, then the entire conjunction still fails, and that's why we see a false over here. So let me just kind of take a break here and see if anyone in class has questions about what we have done so far. Okay, I'm not seeing any questions. All right, so if without any questions, we'll just kind of press forward. Are there any questions about the syntax of how we specify these rules? Okay, so Krishna has a question. Can you explain why it's defined as false once more? Yes. So the reason why there's a false here is the predicate matching engine, when you ask it a question like, is a proper Jedi with the uppercase X, is it will try to make the rules corresponding to is a proper Jedi true. Now, there's only one rule in this case, but it is not limited to just one rule. But since there's only one, this is the one that we can work with. So it will first try to say, let me find a Jedi first, because in order for someone to be a proper Jedi, the first predicate is to make is a Jedi true. So it will basically look through all the facts, and it will find that, okay, Luke Skywalker is a Jedi. Okay, cool. So then it will move forward to owns XY. In other words, X at that point is already bound to the atom Luke Skywalker. So by the time we get to owns XY, this X is no longer really a variable because it is already bound to Luke Skywalker. So now it's trying to find a match of owns Luke Skywalker and something, okay? And it finds this item here, Luke Skywalker owns Anakin Blue. So now Y is also bound. So when Y is bound, and we have both the first and the second predicate being true, now it would evaluate the third predicate on the right hand side of this rule, which is basically asking, is Y, which is now Anakin Blue, a lightsaber? And it finds a match over here. So now we have true and true and true, which means the entire right hand side is true, and X all this time X is Luke Skywalker. So it was able to answer the question and go like, yeah, if we make X Luke Skywalker, then the predicate is a proper Jedi is going to be true. But Prologue is ambitious, okay? It will try its best to answer the question and say, let me try to give you all the proper Jedis, okay? So the next thing it's going to do is to backtrack, go all the way back to the beginning, and it will ask, can you find me another Jedi so I can try to see if somebody else is also a Jedi? And in this case, it will find, oh, we just found another Jedi. Obi-Wan is a Jedi. And then, so X at that point is bound to the atom Obi-Wan. Then it proceeds to try to evaluate the second predicate, which is now owns Obi-Wan and a variable. It's trying to find out what Obi-Wan owns. And looking through all the facts, the predicate engine could not find a match at all. Obi-Wan in this universe, okay, stated by the facts, does not own anything. So it is failing, owns. So this predicate is now returning a false. So when this returns a false and the whole thing here, all three predicates are joined by a conjunction, that means this entire conjunction is now false. So when X is Obi-Wan, then this entire conjunction is false. So that is the reason why it logs a false answer over here, is because it was able to do a partial match to begin with, but it wasn't able to make the entire right hand side of the rule true. So is that okay? Does that answer your question, Krishna? All right, cool. All right, so if you want, so an interesting example in this case is to see if it can it will answer the question differently. When Luke Skywalker owns more than one lightsabers, would it return Luke Skywalker more than once when we ask who is a proper Jedi? Okay, so this would be kind of an interesting example to show what Prolog can do. So now we say Luke Skywalker also owns a different lightsaber, and I'm on the side here, I'm looking up, there's a lot of choppiness. Okay, so may not be a problem on my side. Okay, so later on, I think he has a green one. I'm just looking at pictures over here. Yes, so later on when he gets older, he got a green one. So I'm gonna call it Luke Green, okay? Because I think that one was his, okay? That was not from Vader. Okay, I keep cutting out. Okay, I am not sure why I keep getting cut out. I did change my headset today, but I'm not sure whether that was the issue or not. So we got Bo, Peter, and Carol all typing right now, and they confirmed that everything is okay. And Bo is asking, is male is the same as is a male Skywalker true? Yes, that is correct. And Alexander is confirming that the voice has been fine, so maybe it has to do with certain ISPs or internet service providers. I'm not sure. Okay. All right, cool. So if it is being choppy and you can't quite follow, I can try to reduce the quality of the sound, because I think there's a setting in Discord to do that. Not sure whether I can change it midstream though. That's the thing. Let's see. So I can go to video and voice. All right, so I got a lot of settings over here. In terms of voice processing, I have echo cancellation turned on, but that's only processing power on my side. Noise reduction turned on, automatic gain control turned on, enable quality of surface high packet priority. It doesn't have any settings in terms of voice quality that I can see over here. So, all right. Okay, so Victoria says, whenever the stream from Discord gets choppy, she switches over to the YouTube live stream. Okay, so that might work. And then Bo is asking, will I also have to set Luke Blue to be a Luke Green to be a lightsaber? Yes, I would need to do that. Lower the audio bitrate. Can that be done in Discord? Lower the bitrate. Okay, I'm going to guess it is a channel issue. Okay, Alexander is typing. I'm gonna wait until that is done. Okay, so here's the channel setting. So the channel setting has the bit rate set to 64 kilobits per second, and the maximum is 96 kilobits per second. So I can try to reduce that, and I can reduce it to, let's halve that. Okay, I'm gonna chop it in half. Hopefully that is not gonna negatively impact everybody. So let me save changes and then get out of the configuration window. How is it right now? I just made some changes to the bit rate. Okay, I'm not getting any feedback. Still the same? Okay. All right. So we'll keep this like this for a while and see if it makes any difference like a little bit later on. All right. So getting back to the program, I'm still keeping an eye on Discord, so you guys can go ahead and keep typing over there. So I have to indicate that Luke Green is a lightsaber, so we have to say is a lightsaber Luke Green. Okay, so now Luke Skywalker in this particular universe owns 2 lightsabers. Okay, you only need to own at least one in order to qualify as a proper Jedi. So now the question is, if I ask the same question again, will it answer Luke Skywalker twice? The statement order does matter. Okay, it is actually quite important to have the order. So I'll explain that in just a little bit. So I press Control Enter, and it says clauses of is a lightsaber are not together on the source file. Earlier definition, current predicate owns to this. Use this contiguous is a lightsaber to suppress this message. Okay, so it's just a syntax issue. It just doesn't like the fact that I do not put all the predicates of is a lightsaber together. So that means I can, let me get rid of the message first and then go ahead and do some changes. So what that message is saying is a lightsaber. All the is a lightsaber clauses belong together. So I have to put this right here. So they cannot be spaced out by other predicates. So I think that's the only one that is not following that rule. Okay, so let's give it a try again. Control Enter. There we go. So it says, Luke Skywalker is a proper Jedi. Next. Luke Skywalker is a proper Jedi, and false. Okay, so this is interesting because Luke Skywalker got matched twice, and this is one of the things that Prologue does. Is it would actually do, it explores. Okay, it explores the space using a what we call a depth first search. So after it matches something all the way to the end, it backtracks and then it says, do we have anything else that can match this? Okay. Yes, he is a double Jedi, or Jedi squared. So the reason why it reports Luke twice is it will first match X as Luke Skywalker, and it will match Y as Anakin Blue, and then it will match the third one, which means Luke owns a lightsaber that is named Anakin Blue. So it would match all 3, okay, and then it reports and go like, okay, Luke Skywalker is a proper Jedi. But then it's going to backtrack. It's going to backtrack to owns, and it will try to see if Luke Skywalker owns anything else. And it finds that Luke Skywalker also owns Luke Green in this case. Then it goes forward again, and it will ask, is Luke Green also a lightsaber? And that matches as well. So now we have 2 instances with X being Luke Skywalker, but the first one having Y to match Anakin Blue, and then the second time having Y to match Luke Green. But in both cases, I was able to make all three predicates true, and that's why it returns is a proper Jedi, to be true twice for Luke Skywalker. And Krishna is typing something, so I'm gonna wait a little bit. And do not hesitate to use the voice channel, because sometimes it's just a little bit more efficient to use the voice channel to ask questions. But if you don't feel like using the voice channel, that's fine too. All right, so the question is, if I define owns is a Jedi or is a lightsaber, after is a proper Jedi, would it make a difference? That is a very good question. I do not think so. Because it evaluates the rules, from top to bottom. The only time it makes a difference is when I exchange these orders. In fact, one of the interesting things we can do right now, and I still remember Krishna's question, I'll answer that later, is to exchange these two. Okay, so if I exchange the order of stating the fact that Obi-Wan is a Jedi versus stating the fact that Luke Skywalker is a Jedi, the first one it will try to match is Obi-Wan, and then it will find that Obi-Wan does not own anything. So now the question is, if I change the rules or change the presentation of the facts like the way that I did here, would it print false and then Luke Skywalker and then Luke Skywalker? That is the question. Okay, so let's press Control Enter, and it says Luke Skywalker, and does not report a false because that false was suppressed. It was actually registering the first one as false because Obi-Wan matches is a Jedi, but it failed. Okay, Obi-Wan being X is going to fail owns and is a lightsaber. So as a result, that one was false. But that makes it backtrack right away to say, okay, can we find ourselves another Jedi? And then it finds Luke Skywalker. So that's why the first false was never printed, even though it did happen, but it never got printed because, as a result of the entire thing, okay, it is actually still okay. So this is rather interesting. So this shows you that the ordering is important. So now to answer Krishna's question, which is, if we move is a proper Jedi to the beginning of the program, would it still work? Okay. And the answer in this case is it will still work. Okay, because in this case, is a Jedi is not a recursive definition, and since it is not a recursive definition, it cannot go back and reapply itself indefinitely. So if I press Control Enter, we should get exactly the same answer as last time, and that's exactly what's happening here. So let me just try it one more time, okay? And it reports exactly the same thing. So those are very interesting questions, very good questions. Anything else? Are there any other questions regarding this program as it is at this point? Okay, no questions. So if there are no questions, we're going to go back to the notes again, and then this time we'll explore something that has to do with negation. Okay, so we'll forget about substitution for now, and then we'll skip all the way to how to state disjunctions and negations. So if you want to state anything that is a disjunction, you can basically separate it into a different rule. Okay, so you can specify it or as a different rule. So we have an example like that already. So if okay, not that. Okay, there we go. So when we have basically these two things are they're actually ended together in the system. But an or can also be used you can also use a semicolon to specify a or when you specify the facts. Negation is interesting. So negation is not specified as a not, it is specified as a \+. Okay, so now we're going to specify something called Sith tolerant. Okay, so X is known to be Sith tolerant, only if Y is a Sith, and you cannot find any instance that X does not agree with Y. Okay, so let's go ahead and input these rules into the sample program, and we'll see how we can utilize this to specify is a proper Jedi. Okay, so we specify disagreement now. Okay, so we have to indicate who is a Sith. So we can now say is a Sith, and we can specify Sidious. Okay, Darth Sidious. And of course I cannot remember how to spell. Yep, that is the correct spelling. Okay, so now we can specify who disagrees with Sidious or Darth Sidious. So we have disagrees with, and we'll say Obi-Wan disagrees with Darth Sidious. So this is a fact, okay, to state that Obi-Wan disagrees with Darth Sidious. And now we can specify that rule, okay, Sith tolerant, okay, and X is known to be Sith tolerant only if we can find a Sith, that is Y, and on top we can not find any instances that X disagrees with Y. Disagrees with, and then it's X disagreeing with Y. Okay, like that. Okay, so disagrees with in this case is directional. In other words, if I specify Obi-Wan disagrees with Darth Sidious, it doesn't go the other way. It does not say that Darth Sidious disagrees with Obi-Wan. So it's definitely only going in one direction, but not the other. Okay. All right. So now we can ask some interesting questions. Okay. So we can now ask, who is Sith tolerant? Sith tolerant X, like so. So, but now you have to remember, okay, so think about what the predicate calculus engine is going to do. It's going to try to substantiate X with just about anything, and it will try to see if it can find a Y that is a Sith, such that we cannot find any occurrences of X disagreeing with Y. Okay, so let's go ahead and press Control Enter, and it returns a false. That is not what I was expecting, because I was expecting it to return at least Obi-Wan being Obi-Wan is not Sith tolerant because he disagrees with Darth Sidious, who is a Sith. So all of the other ones, Luke Skywalker, for instance, should match this one, because we should be able to say if X is Luke Skywalker and Y is Darth Sidious, we cannot find instances that Luke Skywalker disagrees with Darth Sidious. So if I change this X to just Luke Skywalker, it should return false. It returns true. Okay, this is correct because because Luke, there's no instance that Luke Skywalker disagrees with Darth Sidious, and as a result, Luke is Sith tolerant. But it was not able to find all the cases where someone or something is Sith tolerant. That was not what I expected, but that's how it turns out. So this doesn't work because it just returns false in this case. All right. So do we have any questions about how rules are specified? Okay, so we got. Okay, I thought there was a new question, but there was not a new question. So do we have any questions at this point? Okay. Rip crash. Are you guys referring to asking who is Sith tolerant and it cannot return a list of atoms that are? No, it's not a crash. It really has to do with how the engine works. So the way the engine works is it's trying to come up with cases and match things. So when x is bound is when x is not bound, when it's a variable like it is here, then it really has to go through every single possible atom to try to find some matches here. And it also has to do with backslash plus is saying, there better be not a case of finding x disagrees with y. So it doesn't give the engine any guidance of where to start looking. Now we can compare that rule with the first rule that we looked into. So this rule is entirely different because the first thing it does is to specify, let's go look for x being a Jedi. But x being a Jedi is not negated. We are not looking for the absence of x is a Jedi. We're looking for the presence of x is a Jedi, which is a whole lot easier. We can find this and we can find that to match this rule. This is looking for the absence of something. So as a result, since x is not bound to anything with this particular query, y is not bound to anything, but y is easy because I can go through all the facts of is a Sith to find out, okay, who is a Sith? Okay, so y is not a problem. The biggest problem has to do with finding out, whether there's an absence of x disagreeing with y, and the predicate engine just does not do that. So that kind of explains why it returns false, is basically because it cannot find out, it doesn't have the ability to do a global search. Because if it were to answer this question, a lot of things in this entire universe can be called Sith tolerant, because all the lightsabers can be qualified as well. So if you input Anakin Blue, okay, it is Sith tolerant because Anakin Blue does not have a disagreement with Darth Sidious. So any atom that does not have disagree with matching that item with someone who is a Sith, is gonna be Sith tolerant. Okay, so any other questions?
No, it's just the Discord stream. It stopped.
Oh, the Discord stream stopped?
Yeah.
Oh, okay, I did not. Oh, so that's what people are saying, is there a crash? That is interesting.
That was a pretty good answer for a question I didn't think of, though.
All right, so let me go back and re-enable that. Yeah, OBS is still going, so I think the YouTube recording is still going okay, and I just have to...
Yeah, YouTube's still okay.
All right, thank you. I'm just looking for the OBS screen on the list of all my screens. And it cannot... Oh, right there. Okay. There we go. Cool. So we're I think we should be back on Discord now. Okay, so at first I thought the rip and crash comment had to do with mic dropped power. Yeah, so YouTube is still going, and I did not get all the text until just now. Okay, so everything. So I think the problem had to do with my Discord and not you guys, because I just suddenly all those text messages just popped up on my screen. I did not get those things appearing one by one, which is kind of interesting. All right. Okay, so continuing with this particular chapter. So we want to kind of look into what is the mechanism, what is the engine doing behind the scene to get all this stuff done. So everything has to do with substitution. Okay, so Prolog is a substitution engine that does depth first search, and it does backtracking and all kinds of good stuff like that. So when we try to evaluate a rule in Prolog, okay, in this case, the example is using is a proper Jedi, that particular rule is really saying this thing over here. So let's just kind of slow down and find out exactly what it is specifying. Now, this part here, I will start with the part that is easy to understand because we kind of talked about it already. Okay, whatever is to the left-hand side of the rule is being implied, and whatever is to the right-hand side of the rule is the portion that we normally put on the left-hand side of the implication. So this part is no surprise because I talked about this already. X is a Jedi, and X owns Y, and Y is a lightsaber, implies that X is a proper Jedi. Okay, cool. We got that. Okay. So what is special about this particular statement, this expression? What is special about this expression has to do with the quantifiers. So you can see how the quantifiers are slightly different. You can see how X has a universal quantifier, and then Y has an existential quantifier. So why is that the case? It has to do with X is on the left-hand side of the prologue rule, and then Y only appears on the right-hand side. Okay, so that sounds kind of really confusing. So let me go back to the prologue program because this makes it a little bit easier to read. So let me move this bar so I can show the entire rule more completely. There we go. So this is the rule that we are talking about. You can see how X only appears on the left-hand side of the prologue rule. So anything that only appears on the any variables that only appears on the left-hand side of a rule is universally quantified. Anything that only appears on the right-hand side of the rule, in this case just Y, is existentially quantified. So that is the reason why when we translate this prologue rule into a statement using predicates and quantifiers, we basically say that for all X in this entire universe, but Y is existential only. So do we have any questions about this part? In other words, we only have to find one Y to make this true, and we are good with that. But for X, we'll explore every single possible X. Is that okay? All right. Now, this part does not say anything about substitution. I'm just double checking, make sure my stream is still going. So this part does not say anything about substitution. So we can now single out a statement. So when I say a statement, it is simply everything other than the quantification. So if I ignore all the quantification, this is a simple statement that has variables. So now the question is, how does the engine figure out what to use in order to make the statement true? So the answer is it's called a substitution. So a substitution, in this case represented in lowercase s, is once again a set. Okay, so in this class in CISP 440, we represent just about everything as a set. So this is a set. It has two elements. The first element is replacing X with Luke Skywalker, and then the second one is replacing Y with Anakin Blue. Okay, and S itself is known as one single substitution. So a substitution is basically a set where each element maps a variable in uppercase to either another variable or an element of U, and U in uppercase is basically known as quote-unquote the universe, which is basically a set that has all the atoms. So all the atoms are basically everything that is lowercase but not a predicate in the prologue program. So this is called the application of substitution looks like this. So the first letter is the Greek letter phi, and then the second letter is lowercase s in this case. So phi is the statement, and then s is the substitution. So by applying the substitution s, which is replacing uppercase X with Luke Skywalker and replacing Y with lowercase Anakin Blue. When we apply the substitution to phi, and phi is coming from here, which is a part of the prologue rule, then we get the following. This is after the substitution. So we basically ask, okay, let's look at this particular statement after the substitution and see whether it is true or not. And in this case, it really is true. So we know that if we make uppercase X Luke Skywalker, then this particular statement is true. And in prologue, this is also why we can find that Luke Skywalker, in place of X, is going to make the predicate true. Whew. Okay, so do we have any questions about this part of how prologue gets the job done internally? No questions. Okay, let me double check to make sure the stream is still going, because that may be the reason why I'm not getting anything. Nope, the stream is still going. All right. But do we have any questions about prologue? Or at least the basic engine of prologue? Krishna has a question. Can I explain why is a proper Jedi occur twice if the quantifier for owns there exists and not for all? Okay, so it's the quantifier applies to Y and not so much to own. So the question or the answer to that question has to do with not so much the mathematical definition, because technically speaking, if I find one single thing that is a lightsaber and X owns that answers the question of whether X is a proper Jedi or not. But the predicate engine does not just make one single match. It would actually go ahead and ask, hey, let me see if I can find another thing that can make this true. The reason why it does this quote-unquote backtracking and then try out different things is because if Y also appears on the left-hand side of a predicate in prologue, then I can have multiple answers. So it does not quite answer the question, because technically speaking, all we need is just one thing that Luke Skywalker owns that is a lightsaber that makes Luke Skywalker a proper Jedi. But the predicate engine does go back in time. It backtracks and tries to find another match. And that's basically the nature of prologue. It can be turned off using a cut operator, but normally, this is the behavior of the engine itself. Okay. All right. So let me just look at the time. Okay, we got about 20 more minutes. So what we'll do now is to start a different program, also in prologue. But this time we'll ask something a little bit different. Okay, so let me see how we can do that. Do a plus, and we want it to be a notebook here. Create a program. There we go. So this time we want to look into ancestry, relatives, and so on and so forth. Okay. All right. So to express that sort of stuff, okay, we'll go ahead and see if I can find a well-known family tree to talk about. Okay. Yeah, the link is also on the URL over here. So I'm just looking up a well-known family tree, but it has to be a family tree that is kind of deep enough so I can actually, this one may work. And they got names too. Excellent. Okay, so this will work. It's off the screen from your perspective, so you're not gonna see much until I start typing here. Hatfields and McCoys. I'm not familiar with those. But I found this. Okay, okay, let me just put the screen over here for a brief second here. I found the Simpsons ancestry tree, so we're going to put that in, and then we'll start to ask some questions. All right, so we'll start to specify the rules here, or the facts. Okay, so we'll start with the facts. So if you want the this particular program to also be able to differentiate gender, so that you can define what is a father versus what is a mother, and so on and so forth, then gender becomes kind of important. So we'll say is a male, Abraham, and well, this might take a while. Maybe I'll just not specify the gender and only focus on the ancestry. Okay, so we can now specify is a parent of, okay, or to make it easier, parent. Okay, so parent basically says the first item, the first atom is the parent of the second atom. So we say Abraham is parent of Herb, parent Abraham, Homer, and Mona is the mother. So we also apply to Herb and Homer. Okay. Oops. So if you have a typo like what I just did, Prolog doesn't know that you have a typo, and it would think that it is a different atom. So you have to be kind of careful with that. And I also used the wrong name for parent, and once again it doesn't know that this is supposed to be actually just parent, so it would actually complain about that. It won't complain about it, which is the problem. Okay, so with Homer we have Marge being his partner, and then we got Bart, Lisa, and Maggie. Okay, so we have parent Homer, Bart, parent Homer, Lisa, parent Homer, Maggie. Okay, so this gives me just enough facts to start to play with it. Okay, because I can easily ask who is a parent of whom. Okay, so I can say parent XY. Okay, tell me who is a parent of whom, and then press Control Enter, and it will tell me that Abraham is parent of Herb. It will tell me that Abraham is parent of Homer, and so on. Okay, so that's not really surprising. We saw this kind of behavior in the previous program. But now I want to define ancestry. Okay, so how do we define ancestry? Okay, so ancestry, or ancestor of, if X is an ancestor of Y, how do we define that? Now you can go into all the facts and then manually figure out that Abraham is an ancestor of Bart, and Mona is an ancestor of Lisa, and so on and so forth. Okay, but that would defeat the whole purpose of using Prolog, because we want to summarize the relationships using some rules and then have the engine to automatically figure that out for the program itself, so that we don't have to specify all the individual facts. So okay, I'm disconnected again. This is rather strange. This is the first day that this happens to me several times. So maybe I just need to restart Discord. Yeah, it did. It crashed it again. And William is typing something. I'm gonna wait until he's done. Oh, or not. All right. So when we need to specify ancestry, the first one of ancestry is just parent of. Okay, so we can say if X is a parent of Y, X is considered an ancestor of Y. Okay, so that's the first rule. Now that we have this rule, we can now use ancestor in a recursive way. So we can say X is an ancestor of Y only if, and this time we say X is a parent of Z and Z is an ancestor of Y. Like that. So once again, it is recursive, right? Because we are now defining ancestry using a recursive definition. Okay, so I can already hear the questions that you guys are asking in your head. Can we flip the order of ancestor and parent when we look at the recursive definition of ancestor? So the answer is no, okay? Because if you flip that order, then it will do it will do an endless recursion. Because specifying the rules exactly like this, it has to end, okay? Because it would chase down the parent relationships until it can no longer find any parent relationship. Then it has to kind of go back, okay? There's no way to continue. On the other hand, if you specify ancestor first, okay, and then you specify parent, then it can just keep on going and going and going, okay? So we'll try it like this first and see if we can answer the question of who is an ancestor of whom. Okay, so we specify x, y as variables, and this time we're asking who is an ancestor of whom, and we should be able to skip a generation now, okay? Because previously when we only ask about parenthood, it is not skipping generations. But when we ask a question about ancestry, we should be able to find Abraham is an ancestor of Bart, okay, and skipping Homer's generation. Okay, so we'll take a look at this one. Okay, so Abraham is an ancestor of Herb. Yep, okay, that's not surprising. Not surprising. Not surprising. Not surprising. Aha, not surprising. This is still just a parenthood. Okay, parenthood. This time we got a one skip of generation because Abraham is grandpa compared to Bart. So now we are locating all the grandparent relationship here. So are there any questions about these rules? Okay, so it will figure out every single grandparent relationship compared to the grandkids. Are we good so far? All right. So we are going to switch the order now. Okay, so I'm going to say, well, what if I switch this order? So we specify ancestor first, and then we specify parenthood next. Okay, because logically it is really the same thing, right? Because if X is an ancestor of Z and Z is a parent of Y, then X is also an ancestor of Y. Seems to make sense, right? So we'll go ahead and press Control Enter here. No problem, okay? No problem, no problem, no problem, no problem. So it keeps going like this because it's looking for, okay, so far so good. And now it's stuck. So it figured out everything the same way as last time, but now it is stuck. And it gives you a stack, basically it's a stack overflow problem. It says it has reached the stack limit. And we got, I'm not sure whether this number tells us the number of recursion, but basically I think this number may be related to the depth of the recursion. So basically we just ran out of stack space because it was not able to stop. Because every time this rule on line 10 fires, it is going to ask, okay, I'm going to ask for parenthood. Ask for another ancestor relationship. It will go here first, and it will find that, okay, that parenthood relationship does not hold. Then it goes to the second rule of ancestor, which is on line 10, and then it will basically recursively try to do the same thing and ask, okay, go find me a person who is so the X is the ancestor of Z, and it keeps going like this forever. Whereas if you replace the first one with parent, eventually it has to end, because eventually it will exhaust every single fact that we have stated using the parent relationship. So once it stops, then it has a chance to backtrack and stops the endless recursion. So this is something that people really need to understand about Prolog, is you always specify the non-recursive definition first when you specify the predicates on the right hand side. So is that okay? Okay, I'm kind of assuming that this is okay. So now we can also specify, grandparents, as in grandpa versus grandma, having the gender thing. But then we also have to state the facts about every single atom, is whether that atom is male or female. So you can combine all of these facts, okay, and then start to make rules and make it kind of fun and interesting to process all of this stuff here. I don't think I want to give you guys a homework assignment for Predicate Calculus, just because there's not enough time for you guys to kind of soak in all the information. For next week, I want to continue a little bit to talk about Predicate Calculus, but I'm going to use a concrete example to illustrate it. Okay, and this is I'm borrowing this from last year's homework assignment, which I'm not going to assign, just because we are running out of time, and if I want to spend any time, I want you guys to spend the time on the A-star and the Dijkstra's algorithm. Yes, well, sort of. So the relationship, the parenthood relationship, is currently specified in a tree, because that's why we call it a family tree. But the how should I put it? So the same thing, okay, we can arrive to the same answer if you specify these as nodes in the tree, and then specify these two as a function in C, then you can do the same thing. But in the program, okay, unless you write a program in a recursive manner and you basically also do what we call backtracking to look at all the possibilities, in the C program, it is not difficult to confirm whether one atom is the ancestor of another atom, but to find all the pairs of the ancestry pairs, that may not be easy to do using a regular C++ or any type of procedural programming language would not be suitable for that task. So is that answering your question, Peter? Okay, all right. So what I want to do is to introduce another example, for Predicate Calculus. Okay, so I'm just going to. This is the homework from last year. Okay, so this one is for figuring out second cousins, third cousins, and so on. Okay, so you can start to think about it. Okay, so I want you guys just to think about it. It is not your homework, okay, but start to think about it. How do you express the logic of figuring out who is your second cousin, okay, who is your third cousin, and so on? Now, once you figure that out, you can also try to figure out cousins with removed. Okay, so who is your third cousin? One generation removed, and so on. But how do you encode all of that stuff into Prolog? Okay, so that's one thing that you can look into over the weekend. In addition to kind of working on the A-star and Dijkstra's algorithm, is to do that. In the exam last year, okay, we'll go over the exam last year as well. There's also a relationship, that is kind of unique to certain cultures, okay, but it is a very specific kind of relationship. It goes like it would be the first cousin on mom's side who is older than the other person. Okay, so there's a very specific term to refer to that person. Okay, so now the question is, how do we express that in Prolog? Okay, so these are kind of interesting applications of predicate calculus. And we don't have enough time to really go into the theory of predicate calculus, but I think by using these examples to illustrate what predicate calculus can figure out, we get at least we get a taste of what it is about, and also what it can do for us. So any questions at this point? We got 5 more minutes. No questions. All right. So if there are no questions, I have some more ideas. Okay, whether you guys want to kind of do this or not is up to you. Is to actually write programs. Okay, I know you're already up to here. You cannot see me, but you're up to here with all your homework and all the studying that you have to do for your final exams. But if you just kind of think about how to implement a program for A-star, or start with Dijkstra's algorithm, which is a little bit easier. So think about that. And you don't have to do it in C or C++. If you know some scripting language like JavaScript, that actually makes it easier, because JavaScript actually has the concept of a set. It also makes a lot of operations involving tuples a lot easier, but that's assuming that you know the syntax of JavaScript fairly well. But if you kind of go through that exercise, I think it will help you understand the algorithms a lot better, because as you write the programs to implement A-star or Dijkstra's algorithm, you will start to kind of understand the concepts a little bit better. And it also makes it possible for you to feed different graphs into the program and have the program to figure out the shortest path. And that way, if you have a lot of printf statements, or if you just kind of analyze what the program is doing with all the different variables, that will also help you deepen your understanding of those two algorithms. So that's kind of a suggested activity if you have the time. I know you guys are probably really busy already, but it might be helpful to kind of think in that direction. Okay. All right, so we are out of topic and out of time more or less today. So next Monday, I am going to reveal the answers to the ungraded assignment for A-star and Dijkstra's algorithm. So you might want to work on that over the weekend, so that way you can compare your answer to the answer that I'll be disclosing. And then I'll talk about some applications of the predicate calculus stuff using Prolog. And if we have time left on Monday, we'll start with the final exam review. And once again, this is a kind of strange semester. Everything is online. So the test from last semester is a good idea in terms of the scope of the exam, but the format of the exam is going to be different. And I have already taking a look at all the answers for the second exam. So now is the really kind of difficult task of assigning points to different types of answers. How many points should this kind of answer get, and so on. So that's going to take me a little bit of time, but I got feedback for all of the exams in exam 2 already. So you can go into your specific document and kind of see what I wrote down in your particular answers. All right. So I am going to stop the lecture at this point. I'm going to turn off the live streaming, but I'll stay online for about another hour in case anyone has any questions. The final exam, okay, that's an interesting question. Alex asks whether the final exam is cumulative or not. So the answer I'm going to give is it is not intentionally cumulative. I know it's not that much of an answer, but that's the best I can say, because you still need to remember all your understanding of what a set is, set operations, unions, element of, that sort of stuff. You still need to know what a tuple is, okay? Proof by contradiction, interestingly, is still going to be important. I haven't really decided on the questions yet. So it's not intentionally cumulative, but it is still good to retain the knowledge of most of the things that we have talked about. Brander asks, so Monday will be me going over the ungraded assignment and the graded homework application of Dijkstra's. There's no graded homework for Dijkstra's. I did not assign that homework. So William's question is, will we have the grades for the second exam before the final? I will try my best to give you the points of exam 2, but the corrections are already in the document that I have shared with you. So you should be able to find it in as a shared document with you. So in addition to your answer, I would have typed my feedback to your question, to your answers, so you should be able to see that. Krishna is asking, how do we see the comments for exam 2? So you have to look into the shared document, and so I'm guessing if you ask the question, you were able to find the exam, but you cannot find my feedback or my comments. It should be highlighted because they should register as suggested changes but not accepted yet. And then Brand is asking, well, how many questions? I haven't decided yet. Okay, so that's one thing that I have not decided is the number of questions, because it all depends on the types of questions. So most of the questions in the final exam will be on the material that is after the second exam. So that's basically all the graph stuff and predicate calculus. So those questions, I'm not really quite sure yet, what kind of question I'll be asking, because this is fully online and I'm adjusting the type of questions that I'll be asking in an exam, because of the format of the exam. So Krishna, were you able to find your exam 2 and find my feedback in the exam? Okay, looks like my Discord is crashing again. Oh, maybe not. It's just being a little bit jerky. Okay, so you found the exam but not the feedback. Okay, so that means the way I'm inputting the feedback is not showing on your side. Okay, so I need to find a different way to make that show, because I put in my changes, but it probably on your end you cannot see it because it's not accepted as changes yet. This is going to be a pain, because now I have to go through every single one of them and change the way I provide the feedback. Oh crap. All right, so I'm going to look into this and see if I can find a mechanism to highlight my my feedback, because I put feedback into every single one, except they are registered as suggested changes. So that's why you cannot see it, because you from the perspective of the document, you edited the document prior to my editing, and because I own the document, so it's not going to show my suggested changes to you. So that is the problem. I have to go find a way to fix that problem. It's not going to be like that. Okay, the question is, will I be dropping some of the questions from the grades on the second exam? So the way I will grade it is to see if I find, or how much evidence I find of a particular, of the understanding and the application of knowledge for a particular point. Okay, I can give you an example. So for the questions of proving in propositional logic, okay, I'll be looking for evidence that the person who answers the question understands how to convert any Boolean expression into a CNF. Okay, so if a particular person completely answers a question, showing me that the conversion is 100% correct, it is fully step by step, there's no mistake and whatnot, then it'll go like, okay, well, that person may run out of time and not be able to answer the other two questions, or the other, I think, 2 or 3. But at least there's evidence that that person knows how to do it. Okay, as opposed to someone who gives me a lot of derivations for all of the questions, but the answers are all completely wrong. Okay, so that person, even though has answered more questions, but there's no demonstration that that person actually knows how to do it. So it's not quite dropping the lowest score per se. So I'll be grouping the questions into categories. There are mainly 3 categories, okay? And then for each category, I'll be looking at, I'll be looking for evidence that somebody fully understands the concept and was able to, answer the questions completely. Someone who answered the questions completely for 1 or 2, but ran out of time for the rest, and so on. So it's going to be a little bit different compared to how I grade the first exam. Brand is typing something. Okay, so Brenda is asking, so around when do I think I'll be getting the exam 2 graded? This weekend? Well, it depends on whether I ran into technical difficulties or not. I want you guys to be able to see the feedback, so this way you guys know at least what the concept is, or why you got points marked off, or why you got certain points. So I want to work on that one first, and then once I have that, I basically will go through all 45 submissions again, and then apply the point values to the answers. So I got everything reviewed already. I looked at every single answer already. I just need to find out a way to assign points to different types of answers. That's going to be the time consuming part, because I want to be fair. Okay, what constitutes a A, what constitutes a B, a C, a D, and an F. So I need to write down kind of how I want to assign the points, then go through every single exam again in order to assign the point values to each one. So that's going to be a little bit of a time consuming process, but I will try to get it done over this weekend, because I still got 4 days before we meet again on Monday. Okay, so I hope that answers all the questions, and if without any further questions, I'm going to stop the live streaming. All right, so I'm going to stop the live stream. Okay, you're welcome. And if you do have any extra questions, don't hesitate to ask in Discord. You can direct message if it's not related to the whole class, or if it is related to the whole class, you can just go to the general chat channel.